Okay, moving on to chapter 14. Chapter 14 is our first real three-dimensional chapter. All the figures are going to be three-dimensional shapes. And the first half of the chapter is going to be surface area. The second half is going to be volume. The first half, dealing with surface area, we'll be applying a lot of the area formulas that we learned in chapter 12. And then in the second half of the chapter, we're dealing with volume, so we'll have some new formulas there. In the first section of chapter 14, we're dealing with prisms and pyramids. The first page is going to be about prisms. The second page will be about pyramids. So as we take a look at prisms, the first thing we should do is at least define what a prism is. And I'm going to pop over to a YouTube video here and just kind of take a look at a video that kind of talks about prisms. Here is a prism, the two figures over to the left, as well as the figure, the rectangular prism right here. The key part about a prism is these two arrows are pointing at the two bases. So there's two parallel congruent faces, or they're also known as bases, in a prism. They're congruent to each other, and if you take a look at it, each of the shapes are the same all the way through the entire prism. So it starts out at one face and then it moves all the way, and it's exactly the same at the other face of the prism. So if I look at the diagram that we have here, this is a right triangular prism, or a triangular right prism. The term right basically means that if I put the prism and I sit it down kind of like on one of its bases like this, it's going to stand straight up and down. Again, so these are the faces, and when we look for the area of these, we refer to them as bases. And so that is, those are congruent to each other, and they are parallel to each other. These portions right here, there's three of them. Those are called lateral faces. There's one. Down on the bottom is another one, and then on the back side is a third lateral face. These are called lateral edges. Lateral edges. And if I find the area of all three of those lateral faces, that will give me the lateral area of the figure. So the red portion is the bases plus the lateral area. That's going to together give me the total surface area of a prism. So let's take a look at this figure here and let's find what the area of this prism is. So if I look at this thing, let's take a look and find the area of one of the bases first. So to find the area of one of the bases, what I'll do is draw in an altitude. That splits this in half. This will be 8, which means this will be 15. And it's an 8, 15, 17 triangle. So the area of one of the bases is going to be equal to 1/2 of the base, which is 16, times the height, which is 15. Or that'll be 120. So that'll be the area of one base, 120. Two of them together, obviously, will be 240. So as I calculate the total surface area, I'll need to include that. To find the lateral area of this thing, remember, there's 3 portions that are lateral areas. There's this back rectangle, and that one we find by doing 30 times 17. There's 2 of those. There's another one on the front side here, like this. Okay, those are going to be both 30 times 17, and there's 2 of those. And we need to add the bottom portion right here. There's a rectangle along the bottom, and that one's going to be 16 times 30. And together, that'll give me the lateral area of the prism. Okay. And once I add this together with 2 of these bases, which is 240, that should give me the total surface area, which is right over here. And I believe it comes out in the end as, I believe, 1740. All right, let's take a look at the next problem down here. This is a right rectangular hexagonal prism. Again, right just means that if I set it down on the top of the table and put it on one of the bases, it's going to stand straight up and down. Regular hexagonal prism means that the base is a regular hexagon. And so what I'm looking for here is the area of one of the bases. So this is 12, and I know that I can do this multiple ways. I can do this, I know these are equilateral triangles, so let's do 12 squared root 3 divided by 4. And when I solve that, I think I get 216 root 3. That'll be for one of these bases. And then obviously to find the total surface area, I'm going to have to do 2 of those bases, 2 times 216 root 3, and then add the lateral area to it. The lateral area consists of all of these guys over here. There's going to be 6 rectangles that I need to add for the lateral area. So it's going to be 6 of, what is it, 40 times 12, right? Because each of these are 12, and this length going along this way is 40. And so I think that's going to end up being 2880. And so, and this part is going to be 432 root 3. And so together, that gives you the total surface area for that. Now, the other thing you can do here, just as an aside, is if I'm looking for the lateral area of a prism, what I can do is I can take the perimeter of the base. In this case, it's going to be just, 12 times 6. And I'm going to drag it along this length, which is 40. So it's going to be 12 times 6 is going to be the perimeter. And then I'm going to multiply it by the height, which is this 40, the distance between one base and the other base over here on the back side. So times 40. And if you multiply all this together, I believe you do get the lateral area, which is 2880. Okay, that's a prism. Let's now flip over to the back side and let's take a look at pyramids. So we're on the back side taking a look at pyramids. Most of you know what pyramids are. You've seen pyramids, whether it's in pictures or you're familiar with it in past years of taking math. But basically, a pyramid has a base. And in the case of what we're going to be looking at regular pyramids where the base is a regular figure, a regular polygon. And it meets at a single point up here. That's going to be our vertex. Okay, and in the case of what we're doing in this particular book, in this chapter, these are going to be right pyramids, so this is going to be standing straight up and down. It's not going to be a crooked pyramid. Taking a look at some little definitions here, just so that we can move forward together. A here is a slant height. That's going to be the altitude of one of these faces. And these faces are all going to be isosceles triangles. So each of these lateral faces, let's get a different color here. These lateral faces right here, those are all going to be isosceles triangles. The lateral edge will be right here. These are all lateral edges. So in this particular case here, with this being a pentagon in the base, there will be 5 lateral edges. This is a lateral edge. This is a lateral edge right there also. The altitude of a pyramid is going to be from the vertex. Whoops, let's get a different color here. It's going to be from the vertex straight down, and it's going to be right dead center of the regular polygon that is our base. And it's going to be forming a right angle right there. So that's going to be our altitude. And of course the base is going to be down here. In this case it's going to be a square. In this case it's going to be a regular pentagon. So knowing that, there is a formula when we're looking for different things within the surface area for these different types of pyramids. There's the area of the base, there's the lateral area, and then there's the total surface area, which is together one base plus the lateral area. There is a formula for the lateral area. You can find the lateral area if you can find one of the isosceles triangles. You just multiply it by the number of isosceles triangles that you have. Or you can use this formula, which is 1/2 of the perimeter of the base times the slant height. This is the slant height right there. Slant height. Okay, so let's take a look at what we got here. This first problem here is a pentagonal pyramid. That's a pentagonal pyramid. The one we have up above is also a pentagonal pyramid. And let's find the base area and the lateral area for the pentagonal pyramid. Or at least let's talk about how to do that. So for a pentagonal pyramid, to find the base area, if you remember, we're going to need to use the formula 1/2 of the apothem times the perimeter. And the perimeter is just going to be each base edge is 10. So this is 10, 10, 10 all the way around. So we know that the perimeter is 50. We can draw in a little triangle like this. And then we, of course, would need to find this altitude here. We'll need to use some trig. That apothem right there. We need to use some trigonometry to go ahead and find that. We know that if I take 360 and divide it by 5, that'll give me 72 degrees is right here, which means that that angle right there, that little angle right here, is going to be 36 degrees. And then I can use trig to go ahead, knowing that this piece right here is 5, and I can find that apothem real easily. Once I find that, I plug that into that formula. To find the lateral area of the pentagonal prism, that's just going to be using one of these guys right here. What I would do is just find one of the areas of the triangle. I know that the base is 10. I know that the lateral edge, which is these guys right here, those are going to be 18. So if I draw in an altitude, this will be 5, and I can do the Pythagorean theorem. I know this is a right angle here. Do Pythagorean theorem. I believe if you do it, you're going to end up with 17.29 as the slant height, or the altitude height for that triangle. So I could do the area of the triangle is equal to 1/2 of the base, which is 10, times the height, which is 17.29, and then from there multiply that answer by, since there's 5 of those isosceles triangles, I can multiply that by 5 to find the lateral area. Okay, let's try one more problem down here. I'm just going to pick at the easier parts of this thing here. You have the lateral area of the big pyramid. Let's just focus on that right now. I know that PR is 10 and RX is 12. So if I want to find the lateral area, I need to find this slant height here. This is the slant height, or the altitude, of one of the faces. And so this is 6, and so this must be 8. 6, 8, 10 triangle. So the slant height is 8. And so if I want, I can go ahead and use the little formula up above, or I can just find the area of the triangle and multiply it by 4. Let's use the formula for fun. The lateral area is going to be 1/2 of the perimeter of the base. Know that the perimeter of the base is 12 times 4, 48. And I know that the slant height, which we found here, is just going to be 8. And so I believe that the lateral area ends up being 192. The base is just going to be a square. This is the base right here. And I know it's just 12 times 12, so the area of the square on the bottom is just going to be 144. So altogether, if I want the total surface area, I just add those up together, and I have my total surface area of the entire big pyramid. Hopefully that'll give you enough information that you need so you can get started on the homework. And so we'll just give that a try, okay? All right, take care.